Hi, welcome back. This is Professor Ridge, and today's lesson is on section 6.6, Determinants and Cramer's Rule. Okay, the determinant of a matrix A, C, B, D, or A, B, C, D if we're reading columns, is denoted by, we have these straight bars like absolute value symbols, A, B, C, D, and is defined as, okay, so the determinant of A, B, C, D is equal to, and you're going to basically multiply the main diagonal, A times D, minus the other diagonal, C times B, or B times C, doesn't matter, same thing. Okay, and then you subtract those two. So it'll be AD minus CB. So we want to memorize that. Let's try an example. Find the determinant of 3, 2, 1, 4. And again, it's pretty simple, so you can go 3 times 4 minus 1 times 2, which is 12, minus 2, which is 10. Okay, so again, I want you to note that a determinant is a number, the determinant of the matrix. Okay, so the matrix is that array of numbers. It's a thing, an object, and then the determinant of the matrix is a real number, like in this case was 10. Let's do one more. Negative 3, negative 2, 1, negative 4. Well, let's make this a 4. So we're going to get negative 3 times negative 4 minus negative 2 times 4, which is going to get us 12 minus a minus 8, which becomes plus 8. So we get 20. Okay, so evaluating determinants using cofactors. So if we have anything bigger than 2 by 2, this is one of the techniques that you can use. Well, this one, basically anything bigger than 2 by 2. Now, first we're going to talk about minor. So if you have a square matrix, and the entries are square matrix A, and the entries are A sub ij. So again, the I is the row and the J is the column. The minor mij of an entry aij, so minor. The minor mi sub ij of an entry A sub ij is the determinant of the matrix formed by deleting the ith row and the jth column of A. So let me just give you an example. Okay, so if we have matrix A, which is written here, if I want to find m sub 2, 1, so I want the minor for row 2, column 1, this is row 2, column 1. If I delete that row and column, so basically what you do is it's going to be, so if I take A, which is negative 3, 2, 5, 1, negative 8, 5, negative 8, 1, 7, and I want the minor of the entry that's in of this 2, I'm going to cross out the row, the column, and write what's left over. So that's going to be 1, and it's the determinant of that, 1, 5, negative 8, 7. So the minor is going to be 1 times 7 minus negative 8 times 5, which is 7, plus 40, which is 47. Okay, so that's the minor of row 2, column 1. Okay, so let's try to find the minor m sub 3, 2. So again, if I were to cross out the row, the column, and then write what's left over. So let's see, if I do A, this time I'm going to do 3, 2. So it's row 3, column 2 would be that one. right? That's 3, 2. So if I cross out, let's see, A is -3, 2, 5, 1, -8, 5, -8, 1, 7. You don't have to rewrite this. I'm just doing it for your notes here. So M32 is this one. Row 3, column 2. So cross out row 3, column 2. Then what's left over, that's your minor. So 3, 2, -8, 1. And we're taking the determinant of that. So it's -3 times 1 minus -8 times 2, which is -3 plus 16, which is 13. Okay, so a cofactor for a square matrix. Okay, for a square matrix A, the cofactor A sub ij of an entry A sub ij is given by, okay, so we got the matrix A sub ij is equal to -1 to the I plus j power, so that's going to give us positive or negative. If you add the I and j together, if it's even, you get a positive number. Negative, you get an odd. I mean, if it's odd, you get a negative number. And then times the minor sub ij. So m sub ij is the minor of A sub ij. Alright, so let's try one of these. Okay, from the matrix given in the previous example, find each of the following. So let's find the cofactor for so A 2 sub 2 1. So that's going to get us -1 to the 2 plus 1 and m 2 1, which is -1 to the 3, which is -1 to an odd power is negative. M21 from the last problem we did was 47. So we're going to get -47. Okay, and then B, if we do A32, we're going to get -1 to the 3 plus 2 and to the m sub 32. And that's going to get us -1 to the 5. M sub 32 is 13. So we get -13. Okay, so now we're ready to define how to find the determinant of any square matrix. So for any square matrix A, so again, for any square matrix A of order n by n, and of course n has to be greater than 1, we define the determinant of A denoted, and we use absolute value bars. So the absolute value of A is read the determinant of A in this context. And we define that as follows. Okay, so choose any row or column, multiply each element in that row or column, whichever you're doing, by its cofactor, and then add the results of each one of those. Okay, the determinant of a 1 by 1 matrix is simply the element of the matrix. Okay, so there's no work to do on those. The value of the determinant will be the same no matter which row or column is chosen. So if I did a 3 by 3, you can choose any row or any column, you're going to get the same answer, provided you did everything right. Okay, so evaluate the determinant of A by expanding across the first row. Now you can expand by any row or any column. Okay, so if I'm going to expand by the first row, so that's going to give me, remember I'm going to do according here, I'm going to take each element of the first row and multiply it with its cofactor. So 3 is a sub 1, 1, so it'll be the cofactor of a sub 1, 1 plus negative 2 times a sub 1, 2 plus 1 times a sub 1, 3. Okay, so again we're expanding. I rewrote it so I don't have to flip back and forth. Alright, so I'm going to do 3 times the minor of 3, times the cofactor. So the cofactor is going to be negative 1. This is 1, 1, 1 plus 1 times the minor. So cross out the row, the column, so we get 4, 5, 3, 1, plus negative 2 times the cofactor, which is negative 1 to the 1 plus 2, times a sub, or the minor of 1, 2, so cross out the row, the column. So row 1, column 2, so we're left with 2, negative 1, 3, 1, plus 1 times negative 1 to the 1 plus 3 times the minor. So we get 2, negative 1, 4, 5. So again, for each of them, basically you got to imagine crossing out the row 1. So for that one, it's row 1, column 3. So if I had 3, 2, negative 1, negative 2, 4, 5, 1, 3, 1, if I cross out the row, the column, that's the minor for row 1, column 3. Okay, so now I got to work out each of these. So I'm going to get 3 times positive 1. Then I'm going to get negative 2 times negative 1. I guess I should multiply these as I go. And then 1 times positive 1. Okay, so I should have combined these two steps. So again, I'm going to cross multiply. So 4 times 1 minus 3 times 5. Plus 2 times 2 times 1 minus 3 times negative 1. Plus 1 times 2 times 5 minus 4 times negative 1. And that's going to get me 12 minus 15, or 4 minus 15 is negative 11. Plus 2 times 2 minus, or plus 3. 2 plus 3 is 5. Plus 1 times 10 plus 4 is 14. So that's going to be negative 33 plus 10 plus 14, which is 24, negative 9. So you get negative 9. Okay, so Cramer's rule for a 2 by 2 system. The solution of the system of equations a sub 1x plus b sub 1y equals c sub 1. That's the first equation. And notice the subscripts are for the equation. Equation 1, a sub 1. Equation 2, a sub 2x plus b sub 2y equals c sub 2. The solution of that is given by, now x is going to be equal to b sub x divided by d. And y is going to be equal to b sub y over d, where b is just the coefficient, the determinant of the coefficient matrix. So for x's, you got a sub 1, a sub 2. For y's, you got b sub 1, b sub 2. And d sub x. Now this is the way I want you to think of it. D sub x is the same as the coefficient matrix, but you're going to replace the x column with the constants. You're going to put the constants in place of the x column. So the x column is the first column, and I'm going to put the constants in place of the coefficients of x. And the y column we're going to leave alone. So the constants replace the x column. Okay, and then d sub y is going to be, you're going to replace the y column, and you're going to put the constants in place of the y column. The x column will stay the same. Okay? So the constants replace the y column. Okay? So d sub x, you're going to replace the x column with the, and put the constants there. D sub y, you're going to replace the y column with the constants. Okay, so let's try this using Cramer's rule. So x is going to be dx over d. Y is going to be dy over d. So this d is going to be our coefficient matrix. So it's 3, 2. So I'm going to read columns. So the x column's 3, 2, y column's 2, 3, which is going to get us 3 times 3 minus 2 times 2, 9 minus 4, which is 5. D sub x is going to be, you're going to take the x column out, put the 7, negative 2 for the x column. The 2, 3 stays the same. So we get 7 times 3 minus 2 times negative 2, which is 21 plus 4, which is 25. Then d sub y, we're going to take the y column out and put in the constants. So we're going to get 3 times negative 2 minus 7 times 2. So don't forget, you're subtracting. That's the definition. See, that's a minus there. A lot of people forget that. Minus 6 minus 14, which is negative 20. So x is d sub x over d, which is 25 over 5, which is 5. Y is d sub y over d, which is negative 20 over 5, which is negative 4. With 5, negative 4. And that's a very nice way to solve systems also, is using Cramer's rule. Now you can extend Cramer's rule to any size system you want, so let me show you how to do it for 3 by 3, and hopefully you can figure it out for 4 by 4 or 5 by 5. Okay, so we have a 3 by 3 equation. Again, note the subscripts are for the equations. So a, b, c are coefficients of x, y, z respectively, and d's are your constants. So x is going to be d sub x over d, y is going to be d sub y over d, and z is going to be, guess what, d sub z over d. So if you're paying attention to the last one, the way you figure out d sub x is you take the x column out and replace it with the constants. Okay, so D is the coefficient matrix. So D is going to be the A1, A2, A3. Y is B1, B2, B3, and Z's are C1, C2, C3. So D sub x, you're going to take the x column out, put in the constants, B1, B2, B3, and then the y's stay the same, and the z's, which are c's, stay the same. Okay. D sub y would be, now we're going to let the x's and z's stay the same. So z's, the coefficients of z is c. And then we're going to take the y column out and put in the constants. So b1, b2, b3. And then d sub z, same thing. Take the z column out, a sub 1, a sub 2, a sub 3. Y column, leave it alone, b1, b2, b3. Now take the z column out, which is the c's, and replace them with the constants. So we're going to put in d sub 1, d sub 2, d sub 3. Alright, and that's it. So that's, oh, and this is provided, I forgot to write it in the last one. This, you can only use Cramer's rule if d is not equal to 0. So you do d first. If it's equal to 0, you can't use Cramer's rule. Then it's going to be one of the special cases where it's infinite solutions or no solutions. Okay, so d cannot equal 0. So that magically appeared on the other page. Okay. Alright, so D is going to be 3, 1, 2, 5, negative 4, 4, negative 1, 2, 3. And I'm going to expand. I can go by any row or column, but I generally do the first row. Unless there's some zeros, then I'm going to use that row. It makes it easy. I'm going to go 3 times negative 1 to the 1 plus 1 is positive 1. So that's going to be positive 3 times the minor of, so I'm going to cross out row 1, column 1, and I'm left with negative 4, 4, 2, 3. Now, this is going to be plus 5 times negative 1 to the 1 plus 2, which is going to be negative 1 times the minor. Right? 1 plus 2 is 3, so that'll give me negative 5. So a lot of times in books you'll see it'll be 3 plus the minor minus 5 times the minor, and they don't really go into where that negative 1 comes from. Okay? So this book really does a good job of explaining that. Hopefully you got that. So now I need the minor for 5, so cross out the row, the column. Row 1, column 2, what's left over? 1, 2, 2, 3, plus negative 1, 1 to the 1, negative 1 to the 1 plus 3 is 4, so that's going to be positive 1. I didn't do that here, but it's there. And then the minor, cross out the row, column, row 1, column 3, so we're left with 1, 2, negative 4, 4. So we're going to get 3 times negative 12 minus 8 minus 5 times 3 minus 4 minus 1, so it's plus and negative 1, times 4 plus, it's minus a minus, so plus 8, which gets me 3 times negative 20, that's 5 times negative 1, it's 12, and just punch all that in your calculator. Okay, I get negative 67. So d sub x, I'm going to take the x column out and put in the constants, negative 2, 13, 1. And then leave the other two rows alone, 5, negative 4, 4, negative 1, 2, 3. So that's going to be, again, I'm going to expand by the first row. So it's negative 2. The minor is negative 4, 4, 2, 3. Then it's going to be minus 5. It's going to be plus 5 times the negative 1, so it's minus 5. The minor will be 13, 1, 2, 3. And then minus 1. And the minor will be 13, 1, negative 4, 4. Which will get me negative 2 times negative 12 plus 8, no, minus 8, minus 5 times 39 minus 2, minus 1 times 52, minus a minus 4, which is plus 4. I'll just write it this way. So that's going to get me, so I get 40 minus 1, 85 minus 56. Okay, which equals negative 201. Okay. Now we're going to do d sub y, which is, we're going to leave the x column alone from the coefficient matrix, so from the original d. We're going to take the y column out, put in the constants, negative 2, 13, 1, and then leave the z column alone. I'm going to expand by the first row again. So that's 3 times the minor, 13, 1, 2, 3. Minus a minus 2, so it's negative 2 times the negative 1, so here, I'll just write it this way, times the minor, so it's 1, 2, 2, 3, and then minus 1 times the minor, 1, 2, 13, 1, and that's going to get me 3 times 39 minus 2 plus 2 times 3 minus 4 minus 1 times 1 minus 26. And I'll just punch all that in my calculator and get an answer. Okay, so I got 134. And then let's do dz, and then we'll be ready to get our answer. So again, I'm going to leave, take the coefficient matrix, 3, 1, 2, 5, negative 4, 4. Take the z column out, put in the constants. So negative 2, 13, 1. Okay, expand by, we're going to do the first row again. So I got 3 times the minor, which is negative 4, 4. Again, you cross out the row 1, column 1. We're left with negative 4, 4. 13, 1, minus 5, row column, so I'm left with 1, 2, 13, 1, minus 2, so it's plus a negative 2, so that's why I'm writing minus 2. Row column, so I'm left with 1, 2, negative 4, 4, and I'm going to work that one out. So So we get 3 times negative 4 minus 52 minus 5 times 1 minus 26 minus 2 times 4 minus a minus 8, which is plus 8. And that gives me negative 67. Okay, so now I'm ready to solve it. So I got x is dx over d, which is equal to, what was x? Negative 201 over d was negative 67. Punch that in my calculator. And it gives me 3. Y is dy over d. d sub y is 134 over negative 67. It looks like 2 negative. Yep, negative 2. And then z is d sub z over d, which is, let's see, what was that? That's negative 67 over negative 67, which is 1. So my answer is 3, negative 2, 1. And you can check that in the original problem to see that it works. Alright, so that concludes the lesson for 6.6. Go to My Math Lab, complete your exercise there, and I'll see you next time.